Hi everyone. Welcome to this session, Avoid the Silos and Help Build the True Internet of Things. So my name is Vernon, I'm the CTO at Higgins, and what we do is we build the picks and shovels of IoT, so the tools and frameworks that you can use to more easily create an IoT product and service. Previously I was the VP of Software Engineering at Lifex, and before that the CTO at Tools. I'm also the chair of the All Seen All Lands Common Frameworks Working Group. So you might see a little bit of a different slant in this session to what we saw in the keynote, but ultimately covering a lot of the same issues and trying to come to the same end game solution. So what I'm going to cover in this talk is the complexities of the current IoT landscape. I'll prove to you that you already didn't know how complicated this space is and how much it needs to be resolved. Then I'm going to go on to talk about how this affects companies and users. Then an Internet of Silos example, and then finish off with how we can work better together. So first I'm going to start with transport to make sure that we're all on the same page. Some of this will be very obvious to a lot of you, but bear with me. So firstly, the first most obvious transport is Wi-Fi. It uses the 802.11 standard. It's standard on all mobile devices and routers and it's become really ubiquitous for users. It's got great range, great bandwidth, but it is high power consumption and high cost. So when a device manufacturer comes to figuring out whether they want their device to support Wi-Fi, they have to factor in whether or not they can afford the chips and whether or not they can have enough power to run the device. So obviously battery-powered devices are going to have trouble running on Wi-Fi, but a light bulb which has a permanent power input is going to have no problem at all. So some of the examples of Wi-Fi devices are Nestcam, Lifex, Canary, and Honeywell Lyric. One of the point about Wi-Fi is the onboarding experience can be quite complicated because the device has to spin up a soft access point that you need to connect to in order to onboard the device. There's no easy way for the device to connect directly to the IoT device without first onboarding it. Next is Bluetooth Smart. It's standard on most mobile devices, as you all know, and it's becoming increasingly ubiquitous. And it's kind of the flip side of Wi-Fi. It's low bandwidth, it's medium range, but on the positive, it's very low power consumption and extremely low cost. Another thing that in the Bluetooth Smart space, which you may or may not be aware of, is that the smart mesh is being worked on by the Bluetooth Special Interest Group. And what this will allow IoT devices to do is really form a Bluetooth mesh around your entire home, where messages are relayed between nodes to greatly increase the range of Bluetooth Smart and combat that major negative of the transport. Some examples of Bluetooth devices are the Flick, the Lumi, and Elgato Eve. Then we get on to Zigbee. So Zigbee's been around for quite a while now. It uses 802.15.4 standard. It's low bandwidth, it's low range, low power consumption, but the pro that you get is it's extremely low cost. So you can make a device, spec it up, get it manufactured in China, and these devices can be extremely cheap. You can ship them in very large quantities quite easily. Unlike Bluetooth Smart Mesh, which is coming, Zigbee has had a mesh from the beginning, which allows your entire house to be covered in this mesh, and you don't have to have direct contact to each IoT device that you're trying to control, which is great. But it typically requires a hub, because the radio is not commonly available on all the different devices that exist. So currently there's no hubs, routers in your home that support 802.15.4, at least not widely distributed. Your mobile device doesn't support it. So even though it does have these great pros, it's not as ubiquitous as Bluetooth or Wi-Fi. It's also known to have interop and interference problems. The interop problems can occur because it's a standards body and there's lots of different implementations of the standard. And this has kind of caused Zigbee to have a reasonably bad reputation. There's a lot of different bodies, which I'll cover later, that are trying to basically improve on it and make a better transport that has the same pros and cons, but less interop and interference problems. So the most famous example in the consumer space of Zigbee is the Philips Hue lights and the Philips Hue hub. Essentially, you've got these light bulbs that are very low cost and you can have buy lots of them for your house, but without that hub, you can't communicate with them with your mobile. There's also a large amount of sensors and actuators that exist that support the Zigbee spec. Next is Z-Wave. Quite often, Z-Wave and Zigbee are bundled into the same theoretical group, but they're actually quite different. Z-Wave is proprietary, so all the chips are developed by a single manufacturer. It uses different frequencies in different countries, which can offer a nightmare for device manufacturers. It's low bandwidth, medium range, also low power consumption and very low cost like Zigbee. But the pro that it has is because it's proprietary and controlled, it does have better interoperability, and it's also argued that it has less interference than Zigbee. I think the jury's still out on that one. It typically, once again, requires a hub for the radio, and examples are a large amount of sensors and actuators. In particular, you'll find Z-Wave is very highly used in the home security sector. Next is Thread. So here we get to kind of a new standard that's emerging, and it's trying to improve on some of the failings of Zigbee, and I'm kind of really excited by what the potential of Thread. So it uses 802.15.4 and 6 low pan, so that it can get IPv6 over the low energy 802.15.4. And it can be bridged to the cloud relatively easily. Essentially, you can have an IP packet that flows from the end node through the cloud all the way through to another node, and it's an IP transaction all the way through using 6 low pan, which is really exciting. It's low bandwidth and medium range, similar to Z-Wave and Zigbee, and also low power consumption and low cost. It forms the mesh networks. That's part of the spec already, that there can be a thread mesh throughout your house. And the other really exciting thing is that Zigbee devices, because they are also 802.15.4, can be upgraded to Thread. So these large amount of devices that we have out in the market at the moment, if Thread starts to take off, could actually be upgraded to be Thread devices. It's early days, but I see a lot of potential here. It actually started in in Nest, as part of their Nest ecosystem, and then Google spun it out and formed a Thread group around it. So it's got some backing from some pretty major companies. Examples at the moment of devices that support Thread are the Google Home Hub, Nest, as I talked about, and there's more products coming soon. The certification was launched in November. Lastly, on the transports, we have Enocean. Enocean is kind of a special beast because it's ultra low bandwidth. We're talking like a packet or two, if that, and it has energy harvesting, so it's got no power consumption whatsoever. It uses thermal differentials in the environment, or kinetics from your touch, or the expansion of water to power the device just enough to get that payload across, which we think is just super cool. It's medium range and low cost, but does once again require a special purpose antenna and a hub in order to bridge into the wider transport ecosystems. There is a large amount of sensors and actuators that exist already that support Enocean, similar to the way that there's a large amount of Zigbee and Z-Wave. So, as you can see, even just from a transport perspective, there is a large amount to choose from. If you're a device manufacturer coming to this IoT ecosystem and trying to decide what's the best one to use, it's really not clear. Everyone has a pro and a con. Some are old, some are new. But we're not even getting started yet, because next we have protocols and ecosystems that layer over the top. So firstly we have OCF, which was formerly OIC. So OCF is the Open Connectivity Foundation. It's a standards body formed in 2014, and as you've heard from the keynote, is the host sponsor of this event. It sponsors the Linux Foundation IoT project, which provides the open source reference implementation. And that's really the first important thing to know about OCF and IoT, is that OCF is a standards body. It presents a standard, confirms a standard, and then there can be different implementations of that standard. And here you can have interop issues, as I was talking about with Zigbee. So IoT at the moment is the major sponsored one from OCF, but there are other projects. Project Soletta is another project that's out there of the implementation of OCF. And I think we need to be really careful that in this setup where we have a status body that is different from the code organization, that we make sure that they stay in lockstep with each other, otherwise we can end up with some of the mistakes of the past. So there are no shipped devices yet, but there is really strong progress on the specifications and a really solid architecture ideas. I like a lot of the code ideas that are behind IoT and OCF, and there's a lot of merit there. It uses a resource-based REST model, which is what Greg Gertz was talking about in the keynote. If any people have kind of worked with web development, it's obviously very prominent there. And I think the great thing about REST is that it does allow those mobile developers, those web developers to move across more easily to the embedded space, because it's working with a model that they've been using for many, many years now. And it's, of course, transport agnostic as well, which you really want a protocol to be. It's currently available on Linux, Tizen, and Android, and the prominent members of the OCF are Intel, Samsung, Microsoft, Qualcomm, Electrolux, Cisco, and GE Digital. So there's lots of heavy hitters in there, and a lot of big companies behind this standard. Next we have AllJoin. So AllJoin started as a Qualcomm project It was made open source in 2013, and the All Thing Alliance was formed around it as a Linux Foundation open source project. It's fully open source, and I think the really interesting thing about All-Join, and it's what's led it to be in the position it is right now, is it's a code-first approach to IoT. So there's not a lot of sitting around and coming up with specifications and iterating on those without also building the code and delivering the devices that implement them. So this has allowed over 250 million devices to be in the hands of consumers right now. And I think that's something that's, even in this fractured environment, is a massive achievement for an IoT body to have accomplished. It differs from OCF in that it uses a client-server RPC model. This is where you essentially call methods on the server as a client as though that server was local to you. And it is also transport agnostic. It's officially supported on iOS, Android, and Linux, and Windows. The Linux is predominantly to support OpenWRT, which is obviously a great platform for all doing to be running on a router or equivalent. The prominent members are Philips, LG, Sharp, Electrolux, Microsoft, Qualcomm, Haier, and Canon. And no, you didn't read that wrong. There are a large number of companies that are members of both of these organizations. I will just leave you to think about that for a few slides before I come back to it. So Apple's HomeKit. As everyone knows about Apple, everyone knows about HomeKit. There's a lot of marketing spend behind it. And it's Apple's answer to IoT. It was initially announced in 2014. Everyone wants it. All these users, they're screaming for it on Twitter, and the first hand from LifeX, this is our biggest complaint that we had daily was that give us HomeKit, give us HomeKit. But if you ever questioned somebody on why they wanted HomeKit, they had no strong reason to give you why they wanted HomeKit and why our company should be devoting months and months of development and be giving a slice of our profit to Apple. And this is a huge problem in IoT because Apple's putting that marketing spend behind it and this really kind of image that they're trying to portray, but they don't actually have any backup to deliver it, and people kind of want it, but for no reason. So it's the tallest walled garden in IoT. You heard the term walled garden talked about in the keynote, and if you're not familiar with the term, in technology it's essentially where there is a closed ecosystem that you either need to pay to get into, or there's some kind of other hurdle that you need to pass in order to be part of that ecosystem. And yes, it does give you a great user experience because things are more guaranteed to interact with each other, but it also hurts the overall technological ecosystem as a whole because it kind of stifles growth that could otherwise be achieved. So people that haven't actually gone through this device manufacturing hurdle of trying to get HomeKit in the device won't actually know just how difficult it is. But essentially, you need to buy an MFI chip, a made for iPhone chip, and put it in every single one of your devices that you ship. So essentially, Apple wants to tax every device so that they get a slice of every IoT device on the market for revenue. This is not only a problem from a bottom line perspective of giving that money to Apple, but it's also a supply chain nightmare because you need to get those chips from whatever factory in China that Apple's using to your factory, and that has all kinds of hurdles as well. And if Apple runs low on that stock, when you're trying to ship a lot of units, you're not going to be able to ship those units. So it's an absolute nightmare. I personally don't think they're going to be successful long term in this approach, but crazy things have happened to Apple in the past, so who knows. The reason, why do people think they're going to get a great experience out of HomeKit? I guess it comes down to Siri support and Apple's customer and user experience. Everyone's waiting for that one killer app that Apple's going to release. And I think it will happen, it's just very strange to me that it hasn't happened yet. So there is no killer app. The MFI process is very strenuous. And also, because they've got this very strong, highly walled garden, there's a lot of unnecessary restrictions that are placed on HomeKit. So for example, HomeKit APIs are only supported on iOS at the moment, which is another thing that baffles me. You've got OSA, you've got TV. All of these platforms could be running great Internet of Things applications, but you're locked down to only working on iOS, which is quite a shame. Next is Google Weave. So this is not yet public, but I feel quite good about the approach that they're taking. We're part of the Google Brillo and Weave early access program, and if you're not a part of it, I encourage you to join. It's quite easy to get in there, and then you can kind of gauge where they're at, see the mailing list, see the code, etc. And yeah, I feel really good about the approach they're taking. They're listening to the manufacturers, they're listening to developers, and they're putting the customary Google engineers behind all of their efforts. It will likely be heavily coupled with Google's cloud, and that may or may not suit your business and the way that you're trying to work. But it is understandable that a company like Google is going to have some interest at the end of the day into what they're trying to achieve. It uses a resource-based REST model, similar to what OCF and IoT use, and it is initially focused on Wi-Fi and the BLE or Bluetooth Smart. I can't say much more, but if you're interested, as I said, join the Early Access program. This is another WTF of IoT. So Nest Weave and Google Weave are different things. And Nest gets the true IoT needs to be proximal. So they've come at it from a very different angle to Google, where you have Nest devices and devices that are inside the Works with Nest walled garden that talk to each other proximately using Thread and Nest Weave. It's a funny thing to talk about. I find it a funny thing to talk about because I really like the approach that they're taking. I think it definitely needs to be proximal, and I think that Thread is a great way to achieve that. Nest Weave is a great protocol to layer on top. But I disagree with the fact that it's working within this very closed ecosystem. So as I said, super exciting technology, but unfortunately part of this works with Nest Garden. There's a very stringent review process to get in that ecosystem. They care very much about user experience and basically all the kinds of things that you'd expect from an Apple review process for the App Store, you'll find when you're working with Nest. It's kind of funny, you may have seen some of the articles that have talked about this in the past few weeks, but Nest seems to run almost like an Apple-like company within Google, and this has pros and cons. You get a great user experience, but you also get that closed ecosystem. And the reason that is that the core of their team is actually ex-Apple, so that's kind of where they came from. Also, they're low power and low latency, just because it's running off Thread. They have devices that need to exist in the home on battery for a very long time, such as their Nest Protect, and so they want a very small footprint in the home. The fact that it is separate to Google Weave, though, is kind of mind-boggling, and I think it's going to cause a lot of confusion in the market. Next, so we talked about transports such as Ocean, Zigbee, Z-Wave, and Bluetooth, and all of these bodies, all these technologies have alliances or organization standards bodies, and they've defined device profiles for people to use so that they can ship support for example, a Zigbee Lightning profile. But when you look into these, such as the Zigbee and Z-Wave device profiles, you find that they're quite fragmented, they're not universally adopted, and at the high level, there's lots of different versions of these from the different transports. So as a device manufacturer or somebody making a service, you end up having a very difficult time because you've got a lot to support. Bluetooth Smart also uses GAP profiles, which are generic attribute profiles. But once again, the device support is not universal. When you look at those, it's kind of missing a lot of the home automation profiles you'd expect to find from a transport that's trying to kind of take on IoT. Lastly, when I'm talking about protocols and ecosystems, I find it useful to talk about Samsung SmartThings. And so this is actually well, it's not exactly the same category as the protocols and ecosystems that I've been talking about in the last few slides, but it does have a reasonable amount of mind share, so I find it useful to talk about. So it was a startup born out of a Kickstarter campaign that was acquired by Samsung in 2014. It's essentially a fully bundled solution, so it includes a hub, a cloud platform, and client apps, and it has a robust device ecosystem including Zigbee, Z-Wave, and Wi-Fi devices. You can go to their website, you can buy the hub, you can select which devices you want to buy, and you can get it all delivered to you, and it all works together. So quite successful. It is actually, for the most part, open. You can go and have your device become part of this ecosystem. You can build smart apps, I think they're called, to run on their platform, which is great. But at the end of the day, Samsung owns the user relationship. They're the ones that have the branded app in front of the user, and this is going to be problematic for a lot of companies that want to get involved in IoT. If they're getting involved in IoT, chances are they want to own that relationship with the user. So as I said, not really competitive, but still worth mentioning. Whew. So yeah, there's a lot of them, and they're really confusing to talk about. Some are the same, some are different, and it's not really clear which way you should go. So when a company wants to get involved in IoT, what happens? Well, for the purpose of this section, I'm going to reference transports, protocols, ecosystems, etc. as stuff. Because it's stuff that you need to do, but it's not essential to what your core product is. So a company wants to make an IoT product or service. The company spends a large amount of time building and maintaining support for their stuff. There is a limited amount of stuff that can actually physically fit in any device. I'm probably at the perfect conference to explain that one. Users are confused about what stuff they actually need and want. As I said before, HomeKit is a great example, but there are others. They might want a Bluetooth device, but they don't really understand the shortcomings of Bluetooth. They just think that there's other devices that have Bluetooth, so that they need Bluetooth everywhere. The end result is a company struggles as they spend most of their time working on the stuff rather than the actual differential value of their product or service. And I think this is really problematic to the whole IoT space, because if there's a bunch of companies coming in here and doing the same stuff and not actually differentiating themselves and focusing on what users want and what their business could actually deliver that is different, then we're all kind of wasting our time. So when a user wants to get involved in IoT, is it any better for a user versus a company? Well, the answer is no, because the user is enticed to buy a starter kit from an ecosystem. The learning curve is steep, but they eventually, get everything onboarded and working. When us as tech people struggle to get IoT devices onboarded and working, you've really got to feel sorry for the user. A new device comes out and they really want it. They've seen the marketing, they really want this new security camera or this new type of light bulb, but it does not work with their ecosystem at launch. So probably the first thing they do is go to Twitter and just slam the shit out of the company for not supporting their chosen ecosystem. But regardless, they eventually buy the device because it offers use cases that they want. And they have to learn a new way of onboarding, they have to learn a new app for controlling the device. And this is a big headache for them. And to get the full benefit of the new device, they then will go out and buy more devices from that secondary ecosystem because they want to support those new use cases that they can't actually do with a single device by itself. So you repeat this process a few times, and now the user has several competing ecosystems, multiple device silos, and a bunch of apps that all function in a unique way. And then we wonder why consumer IoT hasn't taken off yet. So this brings me to the Internet of Silos. So the Internet is great, we all use it every day. It's built on open standards, and it's been really successful. Users use it without even really knowing how it works or not needing to care at all, essentially. But what if it wasn't like that? What if the Internet was like the IoT ecosystem is right now? So imagine for a moment that HTTP never came to be, and the Internet was like IoT right now. Well, it would take 15 minutes to load your first website, 3 hours if you had set up a router. Every time you click a link, you would install a new browser to consume the content. Sometimes you may even need to purchase and plug in a new dongle just to follow a link. When you want to read the news, you forget which of your 10 browsers, which all have different UI and UX, you need to use. There would be the W3C and the W3A. Both would contain roughly the same companies and claim to be the open and only path forward. Yet everyone will keep telling you how fucking awesome the internet is. So how can we improve it? How can we work together to create a better landscape? Because clearly this is not going to work. This fragmentation and device silos, ecosystem silos, is just ludicrous. And all these industry experts are predicting, as we saw in the keynote, 35 billion devices, graphs will go up like this, but how are we actually going to achieve that? How are we going to go beyond just having a bunch of cool devices that sometimes work in a cool way? So I was going to fill this slide with a utopian vision of what true IoT would look like, but the truth is we already know what it looks like. We just need to build it. We know how our homes would look, we know how it would function. The trouble we're having is actually building it, so that's what we should focus on. As I said, hopefully it was evident that we need to do better. We need to grow to become this billion-dollar sector. Ideally, if we grow this space together, and we stop all looking out for our individual companies' concerns, there is bound to be enough revenue to go around. There, we're talking billions and billions of devices, and that's not even revenue. So stop trying to be the platform and start contributing to a real ecosystem, because if we don't manage to create this real IoT ecosystem, there's not going to be any revenue for anybody. And you can own all the users you want, but there's just not going to be anything there to own. So I always like to talk about, I've come from a consumer apps perspective, built a lot of apps for clients, go on the App Store or websites, and it's always about the user. And so I'm relatively new to the embedded community, started basically at LifeX, and it blows my mind how little these types of people will think about users and use cases, because to me, that's what sells devices, that's what sells experiences. So IoT needs to be about users and use cases. Focus on trying to deliver those notable use cases, and you might find that as a side effect, the IoT environment will be improved. Stop trying to be the one thing to be all and end all, but develop real value for your users. And then everything else, well, a lot of the other stuff will come as a side effect of that. Most mainstream users don't even know what IoT is, and they may have devices, but they don't know them as IoT devices. So I think as a whole, it can sometimes be a bit of a dangerous thing to talk about. Focus on usability and solve real problems. I mean, that really comes back to just software engineering in general. If you're not doing that, then in my opinion, you're not really doing it right. So working together with an open source protocol. So the ideal way forward would be a simple open source protocol and cross-platform framework that can exist outside of the walled gardens and bridge between them. Walled gardens are always going to exist. There's always going to be companies like Apple that try to own absolutely everything and create this curated environment. But we know from history at least that that's not going to be the only thing that exists. There will still be the Linux operating system. There will still be these other solutions that exist outside of that and provide an alternate kind of experience for the user. And I think that's really where this open source protocol could exist. This would provide the lowest common denominator for IoT. If we can't speak between devices in one open way, we don't have even just the table stakes for IoT. Currently, there are two competing open source Linux Foundation projects, all joined and IoT, which is an implementation by OCF. I know there's a lot of high-level business at play here, but seriously, can we just figure this shit out? I think this conference in particular is a great place to do that. We've got a lot of engineers here. We've also got some business people, and everyone knows something has to change, so we just need to focus our minds on actually changing it. There are a lot of different ways forward, and I think there's a lot of valid ways forward. So we must pool our minds and resources and efforts, because otherwise, as I said, IoT will not work. So, for those that don't understand, or a little bit more clarification about what an open protocol X would do, essentially we have all those different bodies around the outside, and they would speak a common language and be able to speak to each other. At its most basic level, the open source solution needs to contain schemas for devices and the ability to transfer those schemas from one point to another. There's a lot of other discussions that go on in the open source projects that exist on the internet, everywhere that talks about all these things that these open solutions could do, but at its core, it's getting a schema from one point to another, having a common way to talk about things and then a way to transport that across the network. So it's actually, there's not a lot there that needs to be built. In my opinion, it should focus on transferring with IPv6 over Wi-Fi, Thread, and Bluetooth Smart. And the reason for that is you get a good spread of ubiquitous and forward-thinking technologies. So obviously Wi-Fi is ubiquitous at the moment, Bluetooth Smart is pretty much ubiquitous. Thread, as I said, it supports a certain type of use case that isn't really covered by Wi-Fi and Bluetooth Smart. It's growing, and if we kind of support that as a stretch goal at this point, then you get this ecosystem that's great now and also into the future. The fact that Thread and Bluetooth Smart are able to achieve IPv6 using 6 low pan, I don't know, it's the kind of thing I read and I just like look at it and I just geek out a little bit that IPv6 could be kind of spoken more broadly across these networks, because that would get us back to the same kind of environment that everyone is comfortable with, and I think that would be great. So, also given the focus on IP, cloud can be laid on top using MQTT or CoAP and gateway node. A lot of people that talk about IoT from a cloud-first perspective, it troubles me quite a bit, and I like the keynote that I can't remember who said it, it was Vernon, said, proximal first. And I really agree with that, and that's why I get on board with Thread and with other technologies that allow devices in the home to speak to each other. If I flick a light switch, I don't want my light switch to speak to the cloud, to speak to the light that's 1 meter away. And this is something at LifeX that we pride ourselves on, because all these devices do talk locally on the LAN and create a great experience where you flick a switch, all your lights turn on at the same time because they're speaking proximally. Cloud is great. You need cloud. A lot of revenue for your business may be driven from having that cloud connection. So of course you need it. But solve the proximal piece first and then just layer that cloud on. Because at the end of the day, if we talk about open source protocol on the proximal network getting a schema from point A to point B, The cloud is really just getting it from point A to point B with a point A, B in the middle. Like, it's really just an extension. It doesn't need to be something that's fundamentally built into your architecture, especially not if you're building on an IP. So anything on top of this is nice to have. We have an all-seat face-to-face meeting later this week, and this is the kind of conversation I'm going to be interested in bringing to the table because you need to really focus on what is the core differential value of your project, how is it different to all the other projects, what do you want it to be, and it's great for people to contribute stuff, but when you talk about really strategically moving forward, you've got to know where you want to end up. So I think it's important to know at its very core, what is the least amount of things that needs to be in this open source project in order for it to achieve its goals. So here's a bit of a more complicated diagram that shows what I'm talking about. Nothing here is revolutionary. It's really just highlighting the fact that this is quite a simple problem that we're trying to solve, and we have a bunch of complicated solutions to it. So in the blue boxes, you have IoT ecosystems. You've got Nest, you've got a thread ecosystem that doesn't even exist yet, you've got Bluetooth ecosystems, OCF, AllJoin, Google Weave. And then you've got the three different types of transports that I think are going to be prominent in the future and are indeed prominent right now. So you've got Wi-Fi, Bluetooth Smart, and Thread. And all of these black lines that you can see between these nodes, they are all speaking Open Protocol X on the whiteboard. So that is the common language being spoken between not only these different transports, but these different ecosystems. At the same time, you can still have native devices, which you can see in the yellow boxes. So these are devices right now that could be a Open Protocol X Bluetooth device or a Wi-Fi device, and it sits on the network and it speaks natively in that language. So it doesn't need any kind of bridging to Open Protocol X. Those tiny white circles that you can see there are a small bridge between those ecosystems and Protocol X. And if Open Protocol X is kept as simple as possible, these don't actually need to be that complicated. It's essentially transferring an XML packet to a JSON packet or equivalent payload, sorry. And then you can also see down the bottom left that you've got a cloud gateway node, and then you speak up to the cloud using MQTT or CoAP. I use those two as an example. I just personally think that they're the two that are going to take off the most in IoT. They're lightweight, they use IP, and CoAP in particular I'm interested in because it uses unicast up to the cloud, which I think could be quite interesting. And the other thing I think is interesting about this diagram is the fact that it doesn't care that you have this heterogeneous network between these actual physical networks. So you've got a thread physical network, a Bluetooth smart network, a Wi-Fi network, but then you've got this virtual network between devices that actually, it's not even really bridging because it's just actually a virtual network that contains all these devices. And as I said at the top, now that's an ecosystem. This is the kind of thing that if we can see this happening in IoT, that's when IoT is really going to start to hit it big. Because a user doesn't need to care about these devices, what ecosystem they're part of, what transport they're using. They plug them in and there's a virtual network that contains all of their things. So working together with an open source translator. So that's great, open source protocol, excellent, and something that I'm passionate about working for. I'm having a conversation with a bunch of people this week to see how we can kind of move closer towards that. But what happens if it doesn't work? You're always going to have a backup solution because I'm not ready to give up on IoT just yet. So the next best thing I think is an open source translator. So if we cannot have a single open source protocol, then the fallback should be this single open source translator. We're working with some others looking to get a project like this off the ground, and we're seeking other companies who'd like to get involved, so let me know if you're interested. And essentially it would be a cross-platform solution for plugging in different protocols, different protocol translators. So example would be from X to Y for Z, from AllJoin to OCF for a light bulb. So just a really thin slice of the bigger problem to get from one protocol to another for a particular device. And the way that it's structured that way is that then you can have people contributing small amounts of code that they may have a reason that they want a commercial reason why they want to commit that code, which is great, which is fine. That'll drive them to get it done, but they don't have to solve the whole problem because the whole problem is much more complicated. And converters would then be combined together to provide a sort of translation graph that would increase in density over time. So you'd start off with quite a sparse graph, and then as you've got more of these nodes, you'd be able to kind of fill it out a lot more. So you notice that when you map out a solution, it doesn't actually look that different to the open source protocol. You've still got all these things around the outside. They're still all connected together. The major difference is that they're speaking their own language on the wire. And in an ideal world, you wouldn't do that. But if you have to fall back to the solution, then it's not too bad. They essentially, talk in on this Weave, translate it to Google Weave, and actually go on the other end. This is how you can kind of combine translators together to solve more complicated problems. So if you had OCF to all join for a switch, and you had Google Weave to all join for a switch, then you could get from OCF to Google Weave. And you can imagine if you had a large amount of these connectors, the kinds of paths you could go through in order to reach your solution. So an open source translator will definitely improve the situation, but as I said, the open source protocol is preferable, and I think that's what we all want. But the open source translator approach would leave a large amount of protocols on the wire, as I talked about, which is less than ideal. You don't really want all these different things talking. And I think interop, actually no, interop's not really the issue there. The issue is that you have to have that translator node everywhere, and the translator node needs to be the same version. Otherwise, you're going to have versioning problems, interop issues. And that translator node also needs to be maintained over time. So all these devices that have that translator node need to have a further update process available to get that out there. And if you have old versions lingering around, then you're going to have some issues on the network. Even if the open source protocol exists, the open source translator still has a lot of value. You can see it forming part of the bridge nodes that I had, the little white circles. So we're kind of keen on pursuing it regardless, because we think it does have that value. So working together, final thoughts. Come to conferences and share your knowledge. You're all here, so you're all doing excellent, A+. Get involved in open source projects. Even if you don't commit code, still being part of the conversation can be quite useful. Come and share the perspectives of your company. At the end of the day, you're the user for a lot of these projects, so the requirements that you have need to direct the project efforts. And in my experience, a lot of these companies are part of these bodies, but they don't really speak up, and then they get upset that things aren't going the way that they want them to. Well, if you don't speak up and help guide that process, how can you really expect these developers to read your mind and do exactly what you want? You should try and focus on developing the core value of your product. That differential value, how are you different to your competitors and everyone else in the market? You should focus on that and leverage existing technology for everything else. We heard a little bit earlier today about Web 2.0 and mobile and how they grew to be so successful. Well, a lot of it was off the back of open source projects and code that these companies didn't need to write, so they could pull everything in and focus on just developing that mobile app or just developing that website. And I really am keen to see IoT get to that level of maturity. So we have the power. As engineers and product managers, we actually have way more power than we think we do. We are the ones that build the future. So encourage your companies to think about the success and failure of the larger IoT ecosystem. As I said, if there is not an IoT ecosystem, then there's no revenue for anybody. So try and make a business case for your companies that something needs to happen here, something needs to change in the way that we work. I strongly believe that we all know what is needed, and we just need to be vigilant about achieving it. Thanks. So if you want to reach me, you can get me at aaron@higgins.com. And I think we're a little bit early, so if anyone's got any questions, I'd be happy to answer them.
Can you go back to slides so you can write your email address down?
Yeah.
Thank you.
Can we get the mics?
Thank you.
Thank you.
Hi, so you spoke quite eloquently about creating these translators, but I think at a principal level, inside the translator project above it is security between these various ecosystems. So I'd love to get your thoughts in terms of how do you bridge security that may have a packet encrypted from one technology and then no keys on the side to be from.
Absolutely. Yeah. So I guess I did a list there on the security. But definitely, I should have had that as a con of the open source translator. So basically, any time that you're translating between protocols, you are very likely to be breaking the security model of that protocol. So this is another pro for an open source protocol. You can have that end-to-end security model in place. And that's, for example, when I talk about IP being spoken everywhere, you can have the same security model for your packets, all the way from a 6-LoWPAN device, all the way through to another 6-LoWPAN device, even though in the middle you're talking just regular IPv6. So I guess I don't have an answer to the translator. I know that it is a problem, and I think it would be quite a difficult problem to address. Thank you for raising it.
No, Alexander, your description of the different solutions are very extensive, but you never mentioned the security of the solution. I mean, is it relevant or this is another lie? Because do you believe all these solutions can be fully secure, or it's about this particular solution to be secure or not? Are they potentially fully secure or not?
So you're talking about whether all the ecosystems are comparable as far as their solution and the security of the solution?
No, I mean, if we are to choose one of these solutions to start with, and we want our solution, our final solution to be secure, do we have to consider it like in the choosing? Or they are essentially
it comes down to
the line.
I guess it comes down to what your product's trying to achieve and the kind of footprint that you're kind of trying to work within. A lot of security when you lay it over the top obviously has pretty stringent implications on your product. HomeKit itself is very secure. That's what they claim the MFI chip is for authentication. So that has a very good secure solution. All joint has Security 2.0, which has been very well thought through by a lot of security experts. So there are some that haven't gone to that level of depth with security, but I guess it's really down to investing in the protocol and seeing if it suits your needs. There is no open standard way at the moment to secure IT, if that's what you're asking.
I agree with your ideas. I think it's a really good goal. We tried this ourselves, and my buddy and I were embedded protocol that is agnostic of the underlying transport, specifically because we think it's unreasonable to expect IP to exist in some places. So we figure that as long as you're going to have radio, you're going to have a proximate gateway that can have live force IP into it. I'd like you to comment on that perspective.
Thank you. Forcing IP into
Live force IP.
I guess my opinion, this is something that I push very heavily in LifeX. We're all the time trying to build for the hardware that we currently have, but I think in some ways we can build for the hardware that we have in 2 years' time. And I think when we get to that point, even these low footprint devices like sensors and everything, there is likelihood that they could be speaking IP. I think there's kind of a lot of nicety to having IP spoken everywhere. But the ecosystem also doesn't forbid bridges existing that can bridge. So Enocean is a great example, right? So Enocean's never going to speak IP. Well, I shouldn't say never, but it's very unlikely to ever speak IP because of how low energy it is. And as I said, only a packet or two. And it's a special purpose radio. So there will be need for a bridge into that system. But that doesn't mean that their bridge on the other end can't speak an IP open protocol X. So I guess that's kind of, if there are needs for those type of situations, they can still exist within this environment.
Thank you for the slides. It was very inspiring for me. We are an appliance manufacturer, and most of the questions are there with our competitors, how we can compete and how we can work together, because the end user would like to have a seamless experience at home or anywhere else.
Yeah.
And besides the security measures, as they last mentioned that first get things done. And in the slides you mentioned there is a proximal thing and the internet thing. And if we are thinking about security in the proximal and if we are thinking about security through the internet, I think they should be different. So we should consider the security levels for the personal network and through the internet thing, as you mentioned, the cloud as a layer over this, I think we can find an intermediate solutions. And thank you for the opinions. As you mentioned, if you cannot figure this out, walled gardens will take the role.
Exactly.
Thanks for that.
Yeah, I mean, I'm definitely no security expert. I know within the Alliance, the Austin Alliance, there are a bunch of guys that specialize in this, and I just always revert to their opinion on this stuff.
Last question.
Sure.
Me first. Me couple questions. There's if you look at the wireless technology, and the adult IT, but the adult I believe there was something to go backward, so that we have to register the devices, the SIM, and then they do tunneling all the way and right now they start doing things about connection is basically something similar to Apple or Wi-Fi. They're in work as well. Because you mentioned, not everything has to go to the cloud, like 100 miles away and coming back, and we need access directly from the sensor to the controller, and some to the level of intelligence at the edges as well. So the sensors can help. Anybody is working on this initiative?
So I was
The second one, and you choose which one to answer. The IoT ecosystem, they consider something like content as we mentioned, IP is not always sometimes video. And right now, again, a lot of cloud folks are thinking about this because it has a lot of meaning. Basically, you look for the contents, you don't care what kind of factors. And service providers are actually looking for it. So again, any comments about any ecosystem, think about this. Thank you.
I'll talk to you afterwards. I think that's probably the easiest stuff. If you want to do some of that stuff, you'll be great time. Cool.
Aaron, thank you.
Yeah, I'll come. Sure.
Aaron, thank you very much.
Thank you.